Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content in this channel, please press like, share and subscribe. Press bell icon to get the notifications. If you are first time viewing this channel and directly this video, then I will suggest you to go through my introduction video first to understand the presentation structure of this course content. Today we are at Detailed Explanation Class 3 for Mathematical Induction. What is it? This is Detailed Explanation Class 3. Okay. Before this, we had completed the Introduction of Mathematical Induction, Detailed Explanation 1, Detailed Explanation 2, and this is the Detailed Explanation Class 3. Right? Okay. Now, in first Detailed Explanation 1, we had discussed first four categories of the problem. In Detailed Explanation Class 2, we had discussed the next four problems. Okay, next four categories of the problems. Now, in this class, Detailed Explanation Class 3, we will be discussing for category 9, category 10 and category 11. Okay. Now, what is the category 9? Category 9 says n in inequalities. What do you mean by inequality? Some signs like lesser than, greater than, okay, where we will give the limit. If I am telling lesser than, that means it will be the lesser value than some number like a or 10, then it will be lesser than a or 10. So limit is 10. So such type of problems which are having a limit, such type of problems will come under n in inequality. So in those problems, to show the limit, we will use lesser than or greater than symbol. Okay. So this is n in inequalities problem. Next is variable involved. So earlier we had discussed that n is at base. Okay, this is in first four categories. N is at base. Next, when we went to the category 5, we had seen that n is at power. Okay, n is at power. At that time, at category 5, we can see that a is a constant over there. Whereas in category 10, here x is a variable. It's not a constant. Category 5, the problems are 2 to the power of n minus 3 to the power of 2n, something like that, where 2 and 3 are constant. In this category, category 10, we are using x, y, which are all variables. So this is variable involved in which n is in power. That is category 10. And category 11, it is in second principle. Second principle is the alternative method to solve the principle of mathematical induction. Okay, we will come in detail once we go through this category. Okay, so it's clear now. The roadmap of today's class will be, we will be discussing the three categories of the problem, that are the last three categories, category 9, category 10 and category 11. Okay, so what we will be doing? We will be doing these three categories in today's class. Okay, we will be discussing these three categories. Okay, let me rub this out, these categories. Okay. Okay, my problem is a mathematical statement is represented by Pn. Okay, so this statement is 1 plus 2 plus 3 plus up to n. Okay, sum of n natural numbers. Okay, this is my left hand side, is lesser than 2n plus 1 whole square. 2n plus 1 whole square is in my right hand side. In between left hand side and right hand side, there is one symbol used. This symbol is lesser than symbol. That's why this problem is classified under inequalities type of sum. Okay. Okay. Now, let's solve this problem by using principle of mathematical induction. what is my principle of mathematical induction? It is a three-step approach. So my first step will be the check step, where I will be writing the initial check, which is my P1. So for my P1, what will be my LHS? My LHS will be 1. Okay, my LHS will be 1, because if there is n, then n terms, 1 means 1 term. Okay, as simple as that. Now what will be my RHS? My RHS will be, we can see here RHS is 2n plus 1 whole square. So what we will do, we will substitute 1 in place of n. So it is 2n plus 1 whole square, which is 3 square 9. Okay, so what we had arrived? We had arrived that LHS is equal to 1 and RHS equal to 9, and 1 is lesser than 9. That's why Pn, initial check, is performed and P1 is true. So P1 is true, right? So my initial check is done. What is my second step? My second step will be to come up with the concrete statement. Okay, so my concrete statement will be PM. It will be written as 1 plus 2 plus 3 dash dash up to m is lesser than 2m plus 1 whole square. Okay, so this is my PM statement. As my check statement is true, I derived my concrete statement, which is my PM statement. What will be my next step? Next step is my induction step, where I will write PM plus 1. This is my PM plus 1 step. Okay. Now in PM plus 1, how many terms will be there? M plus 1 terms. For m, there are m terms. So m plus 1, there will be m plus 1 terms. So we will write it over here. This will be my LHS. So my LHS will be 1 plus 2 plus 3 plus dash dash up to m plus 1. Why I had written m here? Because I want to substitute this with my concrete statement. Okay. Now this entire thing is lesser than 2m plus 1 whole square. Okay. So this entire sum will also be lesser than this 2m plus 1 whole square plus m plus 1. Are you getting it? Okay. Let me explain you. If somewhere it is written that x plus 2. Okay. Somewhere it is written that it is x plus 2. Some expression. If x is lesser than 7, then what will be my x plus 2? It will be lesser than 9. If we will do x plus 2 will be lesser than 9. Okay, what we had done? We had added 2 on the both side. Similarly, this term is lesser than this term. Now I will add m plus 1 both sides. M plus 1 on both sides. Then it will be 1 plus 2 plus 3 plus m plus 1 is lesser than 2m plus 1 whole square plus m plus 1. Are you getting it? So I am adding m plus 1. Same thing I will do here. So here I will write it is 2m plus 1 whole square plus m plus 1. What I had done? I had added m plus 1 in both sides. Okay. Or I can say that this value is lesser than this, and this m plus 1 is the additional term which has come due to Pm plus 1. Okay. So this is not a equal to sum. This will be a lesser than. Okay. Okay. So now let us solve it. This will be 4m square plus 4m plus 1 plus m plus 1. Any doubt in this? We had expanded 2m plus 1 whole square. Now this will be lesser than 4m square plus 5m plus 2. Okay, 4m square plus 5m plus 2. After this, what we have to do? We have to first anticipate that how my RHS will look like for Pm plus 1. Once I put m plus 1 in place of n, then my Pm plus 1 will be 2m plus 3 whole square. You just substitute n equal to m plus 1 here, then you will get 2m plus 3 whole square. Now we have to arrange the terms in this 4m square plus 5m plus 2 such that we will come up with 2m plus 3 whole square. So what I will do, in 2m plus 3 whole square, what will be my m term? M square will be definitely 4m square for 2m plus 3. What will be my m term? M term will be 12. So I have to write 12m. Now here I am having 5m. So I will subtract by 7m. Again, so this m term is solved. M square term is there. M term is solved. Now let's see constant term. In 2m plus 3 whole square, what will be my constant? 9. So put 9 here. Here I am having 2. I will subtract 7. So we had solved constant also. So let's take all the terms which all contribute to 2m plus 3. So it will be lesser than 4m square plus 12m plus 9 minus 7m plus 7. Okay. What I had done, I had taken minus common from these two, it will be 7m plus 7, and rest all I had taken 4m square plus 12m plus 9. Right? Okay. Now this will be 2m plus 3 whole square minus 7 m plus 1. Are you getting it? It will be 2m plus 3 whole square minus 7m plus 1. Okay? Okay. Sorry. As 2m plus 3 is lesser than 2m plus 3 whole square minus 7m plus 1 is lesser than this entire sum. Okay. So definitely this entire sum will be lesser than 2m plus 3. Are you getting it? Okay. I will make you understand. This is lesser than somewhat this term will be suppose 6. Okay. If I will take this constant out, minus 7m plus 1, this term out, then my 6 will become 7 or 8, because something minus some variable minus x is equal to 6. If I am removing this x, that means this whatever variable I took first, that will be greater than definitely 6. Are you getting it? So that's why this 2m plus 3 whole square will be greater than this. So definitely it will be greater than this. Okay, this entire statement. So this is 2m plus 3 whole square. Are you getting it? Okay. I can give you another example which will give a clarity between the jump between these two steps. We can write, if suppose x is greater than 9 minus 6. If x is greater than 9 minus, sorry, we had used lesser than, so I will use lesser than over here. X is lesser than 9 minus 6. Okay. If I will remove 6 here, then it will be x will be lesser than definitely 9. If x is lesser than 9 minus 6, then x will be definitely lesser than 9. Same thing we are using over here. Okay, are you getting it? Okay. So this shows that our Pm plus 1 is true. So what will be the RHS of my Pm plus 1? It will be 2m plus 3, and we had achieved that 2m plus 3 over here. Okay, I will rub this out. Okay, so my problem is x to the power of n minus y to the power of n is divisible by x minus y. This is a mathematical statement which is represented by p of n. Now let's start our basic check. Basic check, we are having p1. Okay, in basic check we will substitute n equal to 1. Then what will be my LHS? My LHS will be x minus y. Okay, just substitute n equal to 1, then you will get it is x minus y. Now what will be my RHS? Now this problem is also a divisibility type of problem. This is a mixture of both. X to the power of n minus y to the power of n is divisible by x minus y. So in a divisibility type of problem, what we will substitute in place of RHS? We will substitute a into k, where a is the divisibility number. Okay, like if certain expression is divisible by 5, then my a will become 5, then it will be 5k. Like that. Here divisibility, it is showing x minus y, so it will become x minus y into k. That will be my RHS. So I have to frame my RHS that it should be x minus y into k form. Okay, x minus y into k. So how my RHS will look like? It is x minus y into k. Okay, then only we can say that this LHS is divisible by x minus y. Okay, so if we see RHS, then we are definitely getting RHS as x minus y into k, where k equal to 1. Okay, if I will put k equal to 1, then it will be x minus y into k. Here k is any number. Okay, chalo, move on to next step, which is my concrete statement. So it will be my p of m. So my p of m will be x to the power of m minus y to the power of m is equal to x minus y into k. Okay, so it will be, I will further drill down, x to the power of m is equal to x minus y into k plus y to the power of m. Okay, so here why I had come up with this expression is I want to substitute this in my next Pm plus 1 statement. So let's take Pm plus 1. So third step is my induction step, which is of Pm plus 1. So in Pm plus of 1, what will be my LHS? My LHS will be x to the power of m plus 1 minus y to the power of m plus 1. In place of n, we had substituted m plus 1, right? Okay, x to the power of m plus 1 will be written as x to the power of m into x minus y to the power of m into y. Okay, so x to the power of m plus 1 will be written as x to the power of m into x, and this y to the power of m plus 1 will be written as y to the power of m into y. Okay, now here x to the power of m I will substitute from here, so it will be x minus y to the power of k plus y to the power of m. So this will be x minus y into k, sorry, it's not power, it's into k, plus y to the power of m into x minus y to the power of m into y. Okay, so what I had done, x to the power of m, I had substituted from here. So my x to the power of m will be x minus y into k plus y to the power of m. This is equal to x minus y into k into x plus y to the power of m into x minus y to the power of m into y. Okay, I had opened the bracket, multiplied with x. Okay, now keep this x minus y into k into x term as is. Here you take y to the power of m out, then you take common, then it will be y to the power of m x minus y. Okay, are you getting it? Right. Now in these two terms, x minus y is constant from these two terms, so you take x minus y as constant from these two terms. Then you will be left with kx plus y to the power of m. Okay, so once you take x minus y common from this, then you will be left with kx plus y to the power of m. So this will be again in the form of k x minus y into something. X minus y into something means it is divisible by x minus y. That means my pm plus 1 is true. Okay, so what is my conclusion? My conclusion is pn is true. So here x minus y into some number, so it is divisible by x minus y. That's why my pm plus 1 is true. This completes the category 10 problem. Okay, now we will move on to other category. Let me rub this out. Okay, in category 11 we will discuss second principle to solve the principle of mathematical induction. Okay, now we have a conventional process of solving the problems of principle of mathematical induction, like initial value, after that concrete statement, and after that induction step. This is how we will drill it down. Okay, whenever we will deviate from this process, like initial value, we will take 2 or 3. Okay, 2 or 3 initial values we will discuss in this problem. Okay, 2 or 3 initial values, we will write 2 or 3 concrete statements. Okay, we will deviate from our conventional process. Whenever such type of process is involved, then we will tell it is a second principle. In an alternative method we are doing the problem. Okay, like here the problem is, if a plus b is equal to c plus d and a square plus b square equal to c square plus d square. Okay, if these two are given, then we have to show that a to the power of n plus b to the power of n is equal to c to the power of n plus d to the power of n. If the given data is correct, the given data is a plus b equal to c plus d and a square plus b square equal to c square plus d square. This is the given data. If this given data is correct, then we have to show that a to the power of n plus b to the power of n is equal to c to the power of n plus d to the power of n. In this sum, why given data is important? Here a, b, c, d are variables involved. So we can't directly come up to the conclusion that whether a to the power of n plus b to the power of n is equal to c to the power of n plus d to the power of n just by putting t1 statement and all those things, because these are all variables, right? We don't know what values it takes. So in such type of problems, one initial value is not sufficient to come up with the statement that Pn is true. Okay, Therefore, we will come up with two initial value, okay, check. It's not a single value check, it will be two value check. So we will put n equal to 1. So first check step, we will put P1. So in P1, we will put n value as 1. So this will be my mathematical statement. Okay, this is the given data. This is my given data and this is my mathematical statement. So in my mathematical statement, I will put 1. So I will come to know that a plus b equal to c plus d. Here a, b, c, d are variables. As a plus b equal to c plus d is given data, I can tell that P1 is true. If it is not a given data, it is not possible to tell that whether a plus b equal to c plus d or not by looking into the statement itself. Okay, right. Now another initial value P2 given data, we will get a square plus b square equal to c square plus d square. In this statement you put n equal to 2, then you will get a square plus b square equal to c square plus d square. This is also true. How we are telling this is true? Because this is a given data, a square plus b square equal to c square plus d square. So these two are true, right? Okay, let's write the concrete statements. Here we will have two concrete statements. Those concrete statements will be Pm minus 1 and Pm, two consecutive numbers. Okay, so n is a subset. In that subset 1, 2, m minus 1, m, every numbers are what? Are elements of that subset. Okay, from 1 to n. Are you getting it right? I had told this in our introduction class. Okay, so m minus 1 and m are the part of the subset 1 to n. So if suppose I will prove that my n is true, that means everything will be true. By reverse order, everything will be true till 1. Okay, so I am writing a concrete statements for Pm minus 1 and Pm. So it will be a to the power of m minus 1 plus b to the power of m minus 1 is equal to c to the power of m minus 1 plus d to the power of m minus 1. This will be first, and for second, this will be for first, and for second we will get a to the power of m plus b to the power of m is equal to c to the power of m plus d to the power of m. Okay, by using these statements, now we will show that Pm plus 1 is true. Okay, we will show that my Pm plus 1 is true. It's not that we will show two consecutive, that one m plus 1 and m plus 2 is true, because m plus 1 is true, definitely m plus 2 will be also true if it lies within 1 to n subset. Okay, so we have to show that Pm plus 1 is true here. Now move on to Pm plus 1. In Pm plus 1, what is my LHS? My LHS will be a to the power of m plus 1 plus b to the power of m plus 1. Okay, now it will be a to the power of m into a plus b to the power of m into b. Okay, it's self-explanatory that a to the power of m plus 1 I have written it as am into a and b to the power of m plus 1 as bm into b. Now from here, what should be our aim? Our aim should be to get the RHS as c to the power of m plus 1 plus d to the power of m plus 1. That means all a's and b's should be converted to c's and d's. Getting it? All a's and b's should be converted to c's and d's. How I will convert it? I can see here I am having a to the power of m, b to the power of m, and a to the power of m minus 1 and b to the power of m minus 1. I have to use these two expressions to get it. Now, how I will get a to the power of m plus b to the power of m such that I will get c to the power of m plus d to the power of m in place of a to the power of m plus b to the power of m. How I will get from that? So what I will do, I will just take blindly a to the power of m into b to the power of m as outside. Okay, now a to the power of m is multiplied by a and b to the power of m is multiplied with b. So I will write it down as a plus b. By this, a to the power of m is multiplied by a and b to the power of m is multiplied with b. There will be some further residual steps in this. What are those? A to the power of m multiplied by b, which is not there here, and b to the power of m multiplied by a, which is also not available in this step. So I will subtract those two. So which is a to the power of m into b minus b to the power of m into a. Okay, wherever there is a mismatch like AB and BA, those are the residual terms which are left in this expression. Those things I had subtracted, right? Okay, now what we will do, we will write it down as a to the power of m plus b to the power of m and into a plus b. We will take AB common from here. If we will take AB common from here, it will be a to the power of m minus 1 plus b to the power of m minus 1. Okay, a to the power of m minus 1 plus b to the power of m minus 1. Now see how we had arrived it. A plus b you can substitute by c plus d, right? A to the power of m plus b to the power of m, a to the power of m you can substitute by c to the power of m plus d to the power of m. Now leave about this ab term. A to the power of m minus 1 plus b to the power of m minus 1 you can substitute here from c to the power of m minus 1 plus d to the power of m minus 1. Okay, so everything is converted to c's and d's except this ab. Now let's see how to convert AB to c's and d's. See, I will use this my PM plus 1 and PM statement. These all are not required, as we know from our mathematical statement that what will my PM and PM minus 1 will be. So I am rubbing these out. So we had given that A plus B is equal to C plus D. This is provided in this is a given data. You just square these two terms. What we had done? We had squared these two terms. We will become getting A square plus B square plus 2AB is equal to C square plus D square plus 2CD. Okay, this is A plus B whole square expansion. This is C plus D whole square expansion. This A square plus B square, this A square, C square plus D square are equal by this given data. A square plus B square equal to C square plus D square. So these two terms will be cancelled, right? So you will be left with AB equal to CD. Okay, so you will be left with AB equal to CD. Now you convert this AB also to CD. Now everything is convertible to C's and D's. C to the power of M plus D to the power of M, C plus D minus CD, C to the power of M minus, C to the power of M minus 1 plus D to the power of M minus 1. Okay, so everything is converted to C's and D's. Now we will simplify this. It will be C to the power of M plus 1 plus D to the power of M plus 1 plus C to the power of MD minus D to the power of M into C. It will be plus minus c to the power of md minus d to the power of m into c. Okay, you just open these brackets, then you will come up with this expression. Now this one get cancelled, this one get cancelled, then you will get c to the power of m plus d to the power of m. Okay, so this is how we have to use the second principle to solve the problems where a given data is given and a number of variables are involved in my mathematical statement. Okay, so with this I will come to a conclusion that my Pm plus 1 is true. So hence my Pn will be true, right? So if a plus b is equal to c plus d and a square plus b square is equal to c square plus d square, then a to the power of m plus b to the power of n is equal to c to the power of n plus d to the power of n. Okay, this completes category 11, which is of second principle. Okay, by this detailed explanation class 3, we had covered all the different varieties of problems in principle of mathematical induction. Next, we will be moving to the workshop sessions. These workshop sessions will be having number of problems which will be solved in a classroom. Okay, so we will be skipping some of the explanation in these problems. Okay, some explanations will be skipped in these workshop sessions. If you are happy with the content, please press like, share and subscribe. Thank you and stay connected.